Okay, guys, first step here, this distance plus this distance is supposed to add up to, read that to me one more time, Jacob.
It is supposed to add up to the two fixed points, which is the
And the sum should be a constant. I think you used the word constant.
constant.
Well, constant to me is like a number. What should they add up to? They didn't give me a number here to work with. I gotta be very clever. In this one, but it's supposed to add up to something. Take those two distances and add them up. Now here's where I need your help. I'm sure you sort of what they're using for a constant here. Laura, point P down to F1 is this short one. Even if I do it quickly here, if I take that little segment out of my sketch, this one, and place it like this, like I said, it's not gonna be drawn this, definitely not drawn the scale. Let's say it looks like that. That's this, and I brought it over here. That's the first segment. He says now sum that up with, add to it, the next distance. And that next distance would be this one, the longer one. I'll attach that to the one we have already. That means I'm going to sum them up, add them up graphically. So I add this to it. I want to sort of get this over here. It looks reasonable. That's the sum of the two. Read that definition to me one more time.
An ellipse is the collection of all points in a plane, the sum of whose distances from two fixed points, foci, is a
It's a
constant.
constant. So what do they sum up to is a constant. So Laura, I don't have numbers here. I have no idea whether this right here represents 4 units, and this out here in the red represents 6. If it does, 4 plus 6, the sum is 10, and that's the constant. Or my constant could be something else here. This could be maybe 3, and this could be 7. Or this could be 3, and this could be 8. They just did not give me a specific number to work with. Now, no matter what though, can anyone in this clever class that I've been bragging on tell me this? From this endpoint of the sum of the distances to this endpoint, can anyone look back at the original graph and tell me, even on this rough sketch, what that might match up with back over there?
The distance from negative A to A.
Thank you. Look at this. From here to here, if you lift it off the board, from endpoint to endpoint, take it back, Laura says, Professor, it looks like it might match up with this. It's supposed to. That is supposed to match up every time if this is an ellipse with this segment there. Now, I know how to find the distance there from that, or the length of it. It goes from A to a negative A. So if I subtract those two to find the difference or the distance, am I looking at 2A?
Yeah.
Okay, so this should be equal to, look at this, put it in blue here, 2A. Jacob, hang on a second. Now, let me set that for, answer your question. Let me bring back in my square roots. First one was square root of this squared plus y squared. Add to it, looking at above me here, next one looks like this. And we're saying this is equal to, with Laura's help, which I really appreciate, this is 2A. She says, Professor, even on your rough sketch up there, it looks like it matches up. I'll take it back to the original sketch. Now, guess what we're supposed to do? Which would take me probably until the end of class. We're supposed to clean that up. Now, what you see right now on the board is right directly from the definition for this oval-shaped, egg-shaped ellipse. If a point on here, Jacob, that point, I gave you some numbers here, will not satisfy this, it's not on that ellipse. Now let's try to clean it up. Now I'm not going to clean it up all the way new. You're going to be amazed and shocked at if I should clean it up fully. I'm so tempted to do it. What falls out if I start cleaning up here, doing some algebra. You're gonna say, Professor, are you kidding me? All that cannot be that. Now, Matthew, I'm not gonna do it all for you. We'll do a little bit with you. Can anyone tell me, and this is a common answer I get in most cases, if this is true, I'm gonna start doing some algebra on it. You'll say, Professor, you're gonna have to get rid of those square roots. Now, the way it looks right now, I cannot, I'll just go ahead and just save myself a little time here. I cannot do this. I wish I could. Ooh, would that make life easy? Can anyone tell me why I would not want to do that?
It wouldn't
I think I'm gonna
just
get math
You
first.
don't know what A would be.
Well, something else, and just in terms of the algebra, why would that be not recommended?
you still get left with the square root.
Yeah, because when you square this, if you do it now, yeah, this term here drops out for you, that's nice, square root drops off. This square root drops off for you, for the last term.
Yeah, but then
That's a
you
middle
get
term.
2 root.
Yeah,
x
2,
minus
2,
c squared
this
plus y
times this.
squared. Yeah. Not pretty.
And you can't even multiply those two square roots together, they're just separate. So you got all that mess on the, you know, see on the left-hand side. This side, of course, is 4a squared. I can do that. No, I can't do what you want here, but I still have to get rid of the square roots. So some students get desperate. I've seen some students say, oh my goodness, I want to pass this class, Professor. You do? Oh yeah, Professor, I want to pass it. Can't I just square this, Professor? And then square this one? And then square this one? And I got rid of the square roots. You know you can't. Now, Jacob, recommend to the class what you might, because I am going to finally get rid of a square root here. What would you suggest?
Couldn't we change the square root to the exponent 1/2?
No, even not that.
Oh.
You could, no, I'm not saying you're wrong. You could raise that to 1/2, that's the same as square root. No, something else you might suggest to me. In order to get rid of the square roots, what might you suggest to me to do before I start squaring both sides? Because I would not square both sides right now, that's awkward, I don't know why.
Solving or expanding.
No, something else.
Subtract.
Oh, I heard, maybe move one over, out of the way, still would be awkward. And you might be left with this. You'll see here shortly why I will not let you do this. I'm so tempted though. If I move that over, that's 2a. Subtract the one I'm moving over. Square both sides. Well, at least the left-hand side's gonna be nice. Will the square root drop off on the left-hand side?
Mhm.
Now, Matthew, I will go ahead and expand what's left over. The square root's gonna be gone on the left. I'll expand this out and get,
X squared
okay, some more,
minus 2xc
absolutely,
plus c squared plus y squared.
love it. Now that looks nice. The square root's gone. Nacio. That's what I said, Professor, no way. I'd like to know, the best you could give me, what would the right-hand side look like squared? Now, hang on a second. Nacio, you wanna try? 4a squared.
Yeah.
Hang on.
So we
Minus?
2 would be
Minus x squared.
There's a middle term here.
minus
What's that middle term gonna look like? It's gonna be awkward, but it's there.
Or
Out here, 4a,
I think
4a.
4a
Root x.
x plus c
Yeah.
squared plus y squared.
beautiful, hang on. Now, Nathan, if I square the last term,
Yeah.
I'll be left with square root drops out.
Mhm.
I'm gonna go ahead and expand what's left out, left
Yeah.
here, out.
It's x squared plus two xc, plus c squared plus y squared.
If I were one of those professors that just put it on the board to accept it. Here's the formula, I'm moving on. I can't do that. Now, at this point, from side to side, you guys would say, Professor, I think you can do this for us. Will the x squareds cancel? And no, let me cancel something else that does not cancel. I thought the two xc's will, they will not.
Well, the
C squareds will,
and the y squared.
they will. That helps somewhat. Now, like I said, I may not completely finish it up. I'm left with a negative two xc on the left. I'm left with four a squared. Subtract this business. And, oh, a two xc is remaining. Is it true, guys? Am I left with that? Yes, no, don't let me mess up.
Yeah,
Now, do I have all the square roots gone?
no.
No, I've got to square again. Now, you know you're not gonna square both sides. You don't wanna square again in an attempt to get rid of that square root. You might suggest, Professor, get this term by itself. Start moving around, take it somewhere, Professor, to get to one side by itself. I think it'd be best to bring it over here.
And then subtract, or.
Hang on down there,
add
let's
to
move it
it.
over first. That is moved over, at least it's by itself. And, mark this out, move that. And everything else moved to the other side. I got four a squared. And so I move that two xc over, that's what, four? xc. You gotta keep in mind, we started here. Now, to get rid of this, I do see, I'm gonna do this first. I could divide both sides by 4 first before I square.
Yeah,
Eventually I gotta square both sides. Division by 4,
could you even do four A or
not 4a. There's no a here.
no? Oh, yeah.
Cancel these out, you have this left. And on the other side by 4, at least makes it a little easier, just like Jacob said, something like that. Fatima, darn it, I was not gonna show you the full derivation, I'm almost there. Ramsey, jeez. Now we'll square both sides. I'm gonna eventually get rid of that last square root. Sophia, here it goes. Now when I square the left-hand side, maybe I will stop here eventually, and let's see, you get a squared definitely. When I square the square root, it's gone. Guys, since it is gone, let me go ahead and expand out what is left there. And here's where Matthew is gonna help me. Matthew, tell me.
2x plus,
Hold on.
x squared.
X squared, hang on,
That's
hang
what
on.
I mean, plus 2xc plus c squared plus y squared.
Thank you, sir. There you go. And the other side,
A to the power of 4.
thank you. Look at that, a to the fourth scares me. 2 more.
Two X,
Plus 2.
XCA.
A squared xc, that looks strange, but that's what it is. And x squared c squared.
Yeah.
Please tell me, Nathan, at this point, I was not planning to go this far on this. Are the square roots gone?
Yes.
We start back here. Square roots at least are gone. You go to my algebra here. Let's write this as the distributed by a squared x squared, I guess. Plus 2a squared xc plus a squared c squared plus a squared y squared. I think.
Yeah.
I Okay, quickly. The other side, I still have this. Now, I myself am getting a little nervous. Because I know what the result's gonna look like with some help here shortly. Oh my goodness, Ramsey, why'd you do all this? Okay. Now, looking at it from side to side, I don't know what some terms may cancel. If they
Yeah,
do, I'm
two
happy.
A squared x cubed.
2a squared xc things are gone.
And that's it.
That's it. Now, I would suggest, at this point to get to where I wanna go, let's collect on one side all the terms that contain an x or a y. Let's put the x and y's all on one side to themselves. So I got a squared, x squared. Has an x in it. I think down here I have another one that contains an x.
Yeah.
So let's move that over to join it.
Minus x squared.
Minus x squared, c squared, beautiful. I knew this class could do it.
And then.
I'll wait, and I won't get the y's also. I got this, it's done. I'm just left with what, plus a squared, y squared, that's nice.
And then it's gonna equal a to the
Fourth.
fourth minus a squared is c squared.
Now, stop right there. Looks nice. In fact, it looks real nice. You say, Professor, what else could you do, if anything?
You let these.
At least these two, I could, if it'll help me. I could take out a common factor of what, x squared,
Yeah.
and have this left over. Still got this.
And can you like factor out a on the other
So
side?
you got it, a squared. Yes or no?
Mm-hmm.
Oh. I did not want to, but I'm gonna finish it. It's almost finished.
Can you divide by a squared, c squared?
Here we go. We're gonna now divide for a reason. Divide everything by this. A squared subtract c squared. A squared subtract c squared. A squared subtract c squared. Which is valid as long as I do it on all the terms. You say, Professor, why'd you do that? Because I see on the left, this much will cancel.
You get x
It's
squared
gonna be
over.
x squared over a squared.
And then,
The next term down here, I think the a squareds
will
cancel.
cancel, yeah.
That's y squared over a squared subtract c squared. And of course, the right-hand side's beautiful. That's 1. Now, before you get, look, Nathan, class,
Yeah.
you gotta keep in mind, we start here. This is by definition, we start here. We're now down to here. And we're not quite, I mean, one more step will do it, we're not quite finished. And we're shocked at what now we accept for like a standard form, standard equation for an ellipse. Not quite there. Now guys, this right here,
Common denominator.
hang on, no. This a squared minus c squared, if I go back to my original sketch, suppose I say, let's take a look at this point right here. I label this point on the ellipse. Take a look at any point. Let's take a look at this point right here for a reason. 0B, and let's look at this, the center, and this point out here at the focal point. And say, it might look something like that. Is that true?
Mm-hmm.
Suppose I now do this, try a different color here, and say now, form a small right triangle. Where I know this from here to here, the base of that right triangle is C units. Is this true, guys? It's out C.
Yeah.
C units, so I'm gonna C here. Anyone tell me what's corresponding with the height?
B.
B. Up to here, That's B. I got troubles. Laura, I just thought something you told us earlier. I would like to label that hypotenuse with a single letter also. You said, Professor, my goodness, you got B as one side, C as the other side, only that letter left is A. I'm gonna put an A there. Not just because it's the only letter left. But I'm gonna put an A here. Now, if anyone in this clever class tell me besides that was the only letter remaining, Professor? It had to be an A. Can anyone give me a rationale why?
We're looking for a function matrix.
Something else? It's right there in front of you, but if I don't guide you, you're gonna overlook it. It's right there in front of you. Why might it be wise to go ahead and call it, yes, that hypotenuse must be representing a length of A.
Isn't it that any point, any distance from the foci is A?
Not necessarily.
Because A is equal to B squared, C squared, and if you wanna find B.
By the way, I am going to use Pythagorean theorem here shortly. I am going to put A squared is equal to what? B squared plus C squared? I know the letters are turned around a little differently for the Pythagorean theorem. Is that true, guys? For the hypotenuse being an A? So C squared is equal to A squared plus B squared. In my case, it's A squared is equal to what? B squared plus C squared, as I heard. That's absolutely what we use. Look at this. Would you guys agree if everything's labeled correctly? Hang on now. With that right triangle. Hypotenuse squared is equal to the other two sides squared. Now, if I take what Laura just gave me, if you guys will accept this, could I now rewrite that from Pythagorean theorem as this? I just rewrote it. Therefore, Austin, I now have a replacement for that. That's B squared. Now, if I accept all that, I wouldn't want to do all this. And I got into it. If I accept that, the standard equation, without any shifts taking place, can be written for an ellipse like this.
And that's the formula.
Hang on, that's the equation formula. Now, before I show you how easy it is to be used, but I will need, again, a good reason why I could label that hypotenuse back there with an A. Hang on, before I ask. Class, your instructor is good. I me at the top. We start here. I was a little hesitant about doing all this. We start here. It's now here. And that's what we're going to accept as a standard equation. Before I show you how easy it is to be used for an ellipse, can anyone tell me why might I have placed that A there? This, mine's not drawn on scale. It's right here. Why might I be able to label that as A? And now, before Jacob answers, let me just do one more little item here. We're finished. I just want to get a rationale. You might say, Professor, suppose you had placed it like this and formed the right triangle over on the other side. Would that also be A or B or C? What is that? Is that another A? Other guys, would this be C again?
Yeah.
That's B?
Mhm.
Would this be A here, I guess?
Yeah.
Again? Why? In other words, you guys are thinking about Pythagorean theorem, C squared is equal to A squared plus B squared. Now, since I have two right triangles, both those hypotenuse are labeled as A, give me a good rationale why it might be appropriate to call that A. Jacob.
If we look at the original equation, we'll see that PF1 plus PF2 equals 2A, which means that any point away from the foci has to be equivalent to A.
Look what he's saying. He's saying, Professor, if you take this piece out, that you're concerned about, hypotenuse, is that right? Take it out and attach to it this one, which is another A. These two triangles are congruent. This, add them up, you'll get this. If you take each one of those hypotenuse, put it aside, sum them up, he says you'll get the distance from this corner endpoint to this endpoint, which is 2A. So it makes sense to call that 2A. And I did half of it here on my one right triangle. So it's appropriate to call it A, and we came up with this. I didn't want to do all this. It's 7:06, I had something else I wanted to do before we closed down. Jeez, I got into it. Now, you say, wait, Professor, are you going to hold me responsible for derivation of the standard equation for an ellipse on the final exam? Guys, this is the first time you're seeing this. I cannot, I'm gonna hit it lightly. I'm gonna ask you, can you imagine? That would be the exam. This would absolutely, this would be the exam. This would take us, I'm gonna tell you guys on my little quizzes, sometimes will take, I don't know how I was, you'll take 3 hours if I would stay with you for 3 hours on a one-page quiz. Can you imagine this? Gee, so I can't ask you to do all this, but I want to show you. I can't just give you an equation and say, here it is, use it. I can't do that. A couple of my students were telling me that's what they had seen in the past, like formulas, equations just given to them, and say, use the formula. Well, where did the formula come from? Now on the side here, to sort of close this down, part 2, I'm gonna keep it brief. If you're asked to sketch this, start out with this, x squared over 25 plus y squared over 9 is equal to what? Please tell me, does this look like what we derived?
Yes.
It will look even more like what we derived if I should write this 25 as what, 5 squared?
Yeah, and the 9 is 3
And this is
squared.
3 squared, of course. But I can sketch it. It's a rough sketch. Mr. Park was telling me he went online just to try to find the derivation of maybe the hyperbola, right? Not the ellipse.
Yeah, to how to graph the hyperbola.
Yeah, he said, oh, Professor, I'd go online, look at this. Now to graph this one, and make it short. Guys, I'm proud of you. You got gone through the entire course. If I should ask you, what are the x-intercepts? In other words, replace y by 0. On this, you'll say, Professor Mike, if you replace y by 0, this drops out. It's obvious. The x-intercepts are plus and minus 5. Aren't they? Is that obvious or not? Are the x-intercepts plus and minus 5? Is that 5 squared? Now you show this,
I don't know. I
this.
just learned about drawing.
Those are my x-intercepts. Quickly done. Now the y-intercepts, you replace x by 0. You replace x by 0, this drops out. It's obvious. The y-intercepts are plus and minus 3. We have done a great job tonight. Those are my y-intercepts. If I ask you to collect those, I think I heard the word collection. Connect them. Can I get that oval shape? Not draw the scale here. Something like that. And there's your sketch. Wow. There's your sketch. We're out of time here if I'm not careful. I don't want to run out of time on this last night. Can anyone tell me, I'm not going to sketch it, if this were turned around and the 9 was here and the 25 was here? Oh, I see already. What? Will I still have an oval shape?
Yeah,
Except this time it will be
an egg.
a vertical,
Yeah.
not the horizontal type I see right now. Austin, I could ask you, but I'm running through this derivation, I could ask you, Austin, please tell me the coordinates of these two focal points. Every oval shape called ellipse has them. And they're supposed to be on the longer, they call this a major. They're supposed to be on the major axis. My major axis in this case is the x-axis, the longer one. Austin, I don't want to put you on the spot here too badly, but can you tell me, based on what we've done, where, they're supposed to be inside there somewhere, where these, on my problem, might be located?
Wait, probably 4, 0 and negative 4, 0.
Okay, if you say 4, 0, that's way out near the edge. And negative 4, 0, way out here. Now, I'm not saying you're wrong. Okay? Now, I'm gonna wait further than what I thought I would do. Anyone have another suggestion as to where are the precise locations we're just talking about right now? Of the foci, the two focal points, on that ellipse, and they should be on the major axis, the only guys, the other axis is called the minor axis.
Is it A minus C?
It has something to do with this.
No,
Here.
wouldn't it be a squared minus b squared?
You gotta solve for C. By the way, did I label my focal points back there with a C?
Yeah.
That says, can you solve for C here? Well, I can if I use, it's got C in it, right here.
Yeah. wouldn't it
What,
be
A squared subtract C squared? Let me go ahead and solve that for C, guys. Is it A squared minus B squared
Minus b squared
equals C squared? Now, with the way it looks, what do you think the A is? I had the A back here to be this on the major axis.
25.
What do you think just the A would be?
Oh, 5.
5. Is that true, guys?
Yeah.
5, so this is 5 squared.
Minus 3 squared.
Subtract B, I think B was this part.
3 squared.
Is that what, 3 squared?
Mhm.
So C.
Equals C squared. What's that, 25 subtract 9, is that 16?
Yeah, so
16 is 4.
There you go. And of course, C is equal to, of course, plus minus 4. He says, Professor, that means you're gonna go to this center, move out 4 units,
Yeah.
4 units, and then those two focal points. Absolutely. And to find those, though, I use that little derivation formula there. Absolutely. Now, did you just look at it and find, sort of sense it was 4 and negative 4?
No, because I was trying, in my head, I was doing 2 triangles and like 1 is 3 and I know like each of the hypotenuse is 5, so the other side gotta be 4.
So you're drawing triangles from here,
Yeah.
beautiful, to right triangles. I sort of use the outcome of this little formula here. Yeah, you can find it like that.
And
Okay, now, guys, if I did more, Ignacio, I wish I could do more and have some of these to be shifted. These ellipses could be shifted to the left, they could be shifted to the right, horizontally, vertically, up and down, and that would look a little different, not too difficult though, but a little different. We don't have the time. Now, what I do have the time here, and Jacob, I'll get to you, is in closing, I can't do much with this one. In closing, if, after you leave me, you're asked to sketch this. I'm not gonna do much with this. I'll tell you what to do, but not much. Now, I mentioned circle tonight. We did a parabola with a focus and a directrix. We just did an ellipse with 2 foci, 2 focal points. That was a beautiful job on that. Now, the other conic and slip, I think on your handout, is called the hyperbola. Now, if the sign here, between here is not a plus, it's gonna be a plus for the ellipse. If it's a subtraction, it's a different curve. Will not give you So this is gonna be a hyperbola. I'm not giving you ellipse. And guys, I gotta show you the shape of the hyperbola in case that's really mean you run into it. Before I get into it, just show you a quick sketch and then I'm done. Matthew, can you tell the class if this would have happened on this one, if this had been also a 25,
It's a circle.
that'd be a circle.
Yeah.
Woo. So a circle is a special case of no ellipse. That would now graph into a circle. So I want to just mention that before I leave it. This last one here, strange graph, strange sketch. No derivation, for goodness sakes, on this one. Oh, by the way, you guys enjoyed the derivation? Oh, I heard, I heard a moan, like Professor No. No, Professor, show me the answer. Okay, here we go. Now, my students who have seen some of this, and a couple of my students have, they're telling me though, more than likely, they saw formulas. Here's the formula to find the focus. Here's the formula for this. Here's the formula for that. Tonight I did a lot of this for derivation. Now if you want to graph this without derivation, not much to talk about here. I would think the x-intercepts are plus and minus 5.
Yeah.
And we'll start at the center. Do this. And label this x-intercept. This is an x-intercept. Beautiful. Y-intercept? Wrong. That's what makes this one different. That's what makes this one different. Wrong.
Does it go like this?
Wrong. Whoa, you mean the sketch?
Yeah.
We're talking about the y-intercept. Wrong for the y-intercept. Guys, if I replace x by 0 on the y-intercept, you're going to end up with y squared is equal to a negative 25. And I can't do a square root, so there is none. Now though, to get the sideways horizontal so-called hyperbola, has 2 branches to it. I would say, well, no, there are no y-intercepts, but I am going to still use those numbers in my little scheme here to graph this.
Yeah, it does
We
make sense.
thought it's 3 and negative 3. We thought, but they're not y-intercepts. And I'm going to use them. Go ahead and mark that so I can see it. I'm going to use them for a reason. Not y-intercepts though. Your textbook suggests this. Now, if you're back in elementary school, kindergarten probably, you would enjoy doing this. Even back in kindergarten, the teacher would say, now connect those points, class. And you'd say, oh, I can connect these points. And we'll go from here to here. And drop down. Draw from here to here. Actually constructed a rectangle that picks up those points first. Kindergarten gets all excited about drawing rectangles. Woo. Now, what else would I do in this attempt to get, what on earth does a sketch of this look like? It's not a circle, not a parabola, not an ellipse. Your textbook suggests, and I've seen this used before, now I have students to draw the diagonals and have them to extend outside for a reason. Draw the diagonals from corner to corner. Let me do it free-handed. Goes through the center and through this corner. There's one diagonal. Draw the other diagonal through the corners, through the center. By the way, guys, those diagonals are known as asymptotes. We've heard that word before. So these are the asymptotes being used. Now, I have no choice. I'm going to use those diagonals, asymptotes, as guidelines. I know there are no y-intercepts. I have no choice then. One piece of the graph, it's got to do this. It's got to pick up that x-intercept at 5 and follow, not touch, those asymptotes. The one on the other side, come down, pick up this point, and follow but not touch. You got two branches for the hyperbola. Okay? That's
So that's right.
Is that true? Jacob, you agree with this?
Yeah, yeah.
Okay. Now, two branches? Not right now. I've got two branches. Now, I can go through and show you the derivation of this at all. Now, whether or not we've done enough in this course, the course is finished. For you, the rest of it's gonna be left to you. I will do my best at 4 o'clock to 7 on Wednesday. Mr. Park, I think, is gonna reach out. Are you gonna reach out at all?
Yeah, sure.
Okay, just let them know. He's gonna reach out, he always does. Susan, I think she has a test on, Wednesday. But she says she may contact you guys and even after her test, may meet with you if you'd like to meet. Okay? Now, guys, in closing,